At VETUS we have decades of experience in the design and manufacturing of exhaust systems for boats. For lovely small boats with maybe 10-15 horsepower, but also some pretty hefty units for engines in the hundreds of horsepowers. In this video we would like to share some of that knowledge with you. We will start with the main tasks of your exhaust system, which is to keep the crew safe from toxic exhaust gases and to protect your engine against the entry of water. The main components are the mixing elbow, the waterlock and the gooseneck, which provide protection to your engine and to the crew. We will also look at additional components such as an exhaust alarm, an air vent, which is needed in many installations, but also at lesser known options such as a gas water separator that will make a very quiet installation. During the whole presentation we will look at how to choose the correct equipment for your boat and how to find the correct dimensions for instance exhaust hose, waterlock and gooseneck. Your exhaust system has to transport exhaust gases and also the seawater which was used to cool your engine. It has to do so with the least amount of noise possible. There is however a price that you pay for that. It simply takes energy to remove those gases and water from your boat, and that is called back pressure. Back pressure can have a very detrimental effect on your ship's engine, both in terms of power and fuel consumption. All VETUS systems are designed to have the least amount of back pressure possible. Your exhaust system is also safety related. Exhaust gases are toxic and your engine also uses a lot of seawater to cool your engine, so there's a clear sinking hazard. And your exhaust system, during shutdown of the engine, has to protect the internal parts of your engine against seawater from flowing back through your exhaust system, because that can do extensive damage to your engine. During this presentation we will look at the different operating modes of a marine diesel. At low speeds you want the least amount of exhaust noise possible, both inside and outside of your boat. When you switch off the engine there will be a mixture of exhaust gases and cooling water in these hoses, and none of that water should be able to find its way into your engine. At high power you want the lowest amount of back pressure possible, because back pressure is very detrimental to your engine performance. In winter storage your exhaust system has to cope with freezing temperatures, and during in-water storage the effects of waves should not be able to push water into your exhaust system. We will also look at emergency situations. What happens if you have a lack of cooling water in your system, but also an excess of cooling water? If your engine doesn't want to fire up and you keep on cranking the engine, you will get more and more water in the exhaust system, and we will show you how to remove that. Your exhaust system starts at the mixing elbow. Here hot exhaust gases, which can be 2, 3, maybe even 400 degrees Celsius at full power, are mixed with cold cooling water. Your engine uses a lot of seawater to cool the internal parts, and that seawater is injected into the hot gases at the mixing elbow. Here the temperature drops to about 40, maybe 50 degrees Celsius. So from here we can work with a flexible rubber hose to connect all of the parts. On most yachts the water level will be around this level. So we need to find a way to pump the mixture of exhaust gases and cooling water overboard. And you do that with an item called a waterlock. Water and exhaust gases enter here, and the waterlock provides pumping action to move that water and exhaust gases overboard. So this will pump water and gases to a higher level. Now, in order to even further protect your system, there is a second part called a gooseneck, and the gooseneck protects your engine against waves or on sailboats the heeling forces. If a boat is heeling over, your exhaust might be submerged in water and you don't want water entering your exhaust system, ending up in your engine. And you can form a gooseneck either with a very flexible hose, but we also have goosenecks with rotating tops and bottoms and rotating in and outlets to make for a very easy installation. Why is it so important to protect your engine from the ingress of water? Here we can see an open up engine with the piston which moves up and down in the cylinder wall, the exhaust valve and the exhaust port. If you switch off the engine, it might end in a position where the exhaust valve is open. If water would be allowed to travel in here, it will land on top of the piston. As soon as you start the engine, the piston will move up, and the system is designed to compress air. If there's water in the system, you can't compress water, the system will stop suddenly and it can do extensive damage to your engine. So water has entered the engine, it's on top of the piston. If you start the engine, the piston will move up, the valve will close, you can't compress water, so the system will stop with a bang. It can do damage to your crankshaft, it can do damage to the piston, to the cylinder head, and often it's irreparable damage. Depending on your installation, there can be additional components in the system. First we'll do a quick overview so you know where to place them in the system, and then we'll look into them into more detail. If you have a water-cooled propeller shaft, which is very environmentally friendly since you don't need grease anymore, the cutlass bearing, as it's called, at the end of the propeller shaft needs a little bit of water to keep it cool. Now the propeller shaft is only turning if the engine is running, so it makes sense to take a little bit of cooling water from your engine to cool your cutlass bearing supply. The cutlass bearing, however, is submerged in water, so if you switch off the engine, water might find its way back by siphoning into your exhaust system. To prevent that from happening, you can use an air vent, which creates an airlock so water doesn't find its way back towards your engine. All VETUS marine diesels, marine engines, are supplied with an exhaust alarm. The mixing elbow is typically the first point where temperature starts rising if you have a problem with your cooling water flow. For instance, you might have a plastic bag sucked into the intake grate, your impeller pump is worn out, the supply of cooling water then decreases, and the temperature in the mixing elbow goes up way before you have damage to either your engine or your exhaust system. Every VETUS diesel is equipped with an exhaust alarm, but you can also retrofit them. It's a simple clock that you put on the dashboard. You install a small sensor, a thermal switch, either in your muffler or in the waterlock, and you can even screw them into the hose. And it's a very easy way to get an early warning of problems with your cooling water flow. Normally, we advise to keep this hose from the mixing elbow to the waterlock as straight down as possible. That will ensure a good mixing of cold water and hot gases. But typically on fast planing boats, the hose is quite horizontal, and then you might have hot air on top and cold water on the bottom. Now, to ensure a proper mixing of hot gas with cold water, you can fit a swirler or mixer, as they're often called. We'll also look into exhaust hose in a bit more detail. Hose, of course, needs to be flexible for an easy installation, but you shouldn't be able to kink it, not even under higher temperatures if you have a problem with cooling water flow. Now, the waterlock or muffler has already been discussed, and we'll look into more detail into those, how to select the correct one for your ship. Same applies for the gooseneck. Now, the transom connection is the final part of your exhaust system, and we will look at those as well. The first part of a well-designed exhaust system is the intake grate for cooling water. Your engine is cooled with outside water, raw water, seawater as it's often called, and it is moved into your boat through an intake grate. There's a couple of slats here that filter the water. Now, if the boat is moving in this direction, water is forced inside. So on a sailboat, you don't want that additional pressure mounted like this, so water is only sucked in when the engine is running. So this is the bow of the boat and it's now moving in this direction. On a power boat, it makes sense to do the opposite. Now the water is scooped up, it's forced inside, because a power boat is only moving if the engine is running. So on a power boat, you want the bow on this side and the scoop moving in this direction, helping the impeller pump to supply additional cooling water flow to your engine. A water lubricated propeller shaft needs a small flow of water to cool the cutlass bearing. The cutlass bearing is located at the end of the propeller shaft, close to the propeller, and a small flow of water is enough to cool it. Since the propeller is only turning if the engine is running, it makes sense to take a little bit of raw cooling water, seawater, which is pumped through your engine, to lubricate the cutlass bearing. Be aware that the cutlass bearing is submerged in water, so there's a high chance of water siphoning back towards your engine if the engine is shut down. In the next part we will discuss the siphoning valve, the air vent, to prevent siphoning from happening. All VETUS self-aligning inner bearings are fitted with a special fitting for an easy supply of water to your cutlass bearing. There are two main routes in which water can siphon its way into your exhaust system. One we've already discussed, which is the cutlass bearing cooling water supply. On most marine installations there will be a small T-section here where raw water, seawater under pressure, is bypassed towards the cutlass bearing in order to cool your bearing. When the engine is running there will be positive pressure here, so water is pushed towards the bearing, but if you switch off the engine, water can find its way back to that T-section, gradually siphon into the mixing elbow and fill up your exhaust system. Now once the system is completely filled with water, that water may run into your engine, causing extensive corrosion and even a risk of hydrolocking. The second round is present in all engines, which is simply the cooling water supply. Once the water level gets to about this height, now add 15 centimeters for safety. If this point is below that line, always install an air vent. If the water level is lower, then it's still a good idea to install an air vent, because we think of the water level as stationary, but think of waves. Wave action might force water into your system as well. Now, normally this hose would supply cooling water, seawater, to an impeller pump, and the impeller pump moves the water through the heat exchanger, and here it is forced into the mixing elbow where it's cooling the hot exhaust gases. So from here we have the rubber hose to the waterlock. Now for the purpose of this demonstration I'm simply going to remove the hose. Normally you start the engine and then the impeller pump will push water through the engine. Here we've replaced it with a simple pump in this bucket of water. When I switch on the pump, of course water will find its way through the engine, out the mixing elbow as it should be. And normally when the engine is running, the exhaust gases will help you to remove that water from your boat. If you switch off the engine, due to the high difference, water will still find its way to the mixing elbow. It will be a lot less than when the engine is running, but slowly but steadily your exhaust system will fill up with water. So first I'm going to place the bucket. I'm switching on basically the engine, and we've got a nice stream of water. When I switch off the pump, water will continuously siphon its way into the mixing elbow. And the only way to stop that is to introduce air in the system, here by lifting the pump out of the water. And of course normally you would do that with an air vent. Now an air vent should be placed at a specific location, which is here. So if the water level gets to that risky level or even higher, make sure that you install an air vent, and the proper location is here at the mixing elbow. You remove this hose with a hose to the air vent, another hose to go down to the mixing elbow, and then your system is perfectly safe. And we advise to make sure that the level from here to the air vent is at least 40 centimeters to create enough suction to open the air vent. And then your system will be perfectly safe. If you install an air vent in the system, and it's always a good idea to do so, this is usually the easiest location to place it, but always make sure that you place an air vent after the impeller pump, as there should be pressurized water on it when the engine is running. This is the exhaust manifold with the heat exchanger. Normally, if the engine is running, water is pushed out of this hose towards the air vent. The air vent now feels pressure, so the air intake is closed. Water will then run down into the mixing elbow and follow the normal route into your exhaust system. When you switch off the engine, water is pooling now on the valve. The pressure inside is negative and air will be allowed into the valve. Now these valves are normally very reliable, but it can happen that a little bit of water trickles out of them. So you can attach a hose here, but make sure that that hose continuously runs downhill. If you run a lot in dirty water with a lot of silt, sand and other debris, the valve might stick a little bit open. And if you want a foolproof system, what you can do is remove the inside of the valve, use that same hose, but then you will have a continuous stream of water. But that's an open connection, so it's very, very reliable. Under normal circumstances, the normal duckbill valve works brilliantly, and only a couple of drops of water will get out of the valve. Different manufacturers use different materials in their exhaust systems. At VETUS we've been using highly specialized plastics for over 40 years to design and build our waterlocks, and they can easily withstand normal and even elevated temperatures in an exhaust system. Some manufacturers use stainless steel. Now at VETUS we design a lot of items from stainless steel, but not exhaust systems. There's a very good reason for that. Stainless steel needs oxygen in order to form a protective layer, and that's why it lasts so long. Without oxygen, the stainless steel is very vulnerable, especially to acidic gases. Now, in an exhaust system, there will be very little oxygen present, simply because your engine is using oxygen to burn fuel. Also, most exhaust fumes are a little bit acidic, and that starts to attack the stainless steel as well. And the effect you can get is called crevice corrosion, very small pinhole-like needles in your exhaust system, which will allow toxic fumes and water to get into your boat. Some manufacturers use polyester. Polyester is a great material for boat building, but not for exhaust materials. The exhaust sound from an engine is always vibrating a little bit. And polyester is a great material, but it can't withstand constant movement. And again, it might look perfect on the outside, but you don't know the condition of a polyester waterlock on the inside. Now, at VETUS, we use the exhaust alarm to give a very early warning that the temperature is rising. There won't be any damage in the system yet. If you decide to ignore that exhaust alarm, or you don't have one fitted, after a couple of minutes your engine temperature will start to rise as well, because there's a lack of cooling water flow. Usually the engine temperature will rise way before even your exhaust temperature starts to rise to a dangerous level. So your temperature needle on your engine will start to rise, and typically there's an alarm fitted to that as well. Now, if you decide to ignore the high temperature alarm of your engine, the next step is your cooling water will start to boil, and it starts to escape your engine in a rather dramatic way. If you decide to ignore that, unfortunately your engine will seize up, doing a lot of damage to the internals. And all of that happens way before there's any damage to your plastic exhaust system. Now, what can happen is that there's a lack of cooling water flow, not enough to overheat the engine, but also not enough to cool your system. Still, the exhaust alarm will sound way before there's any damage, but in extreme conditions such as lifeboats, rescue boats, the military, they have to press on. Now, for those highly demanding circumstances, we have Navidurin, which is called the HD waterlock, the heavy duty waterlocks, which can withstand even higher temperatures. VETUS exhaust hose is manufactured to an extremely high standard. Exhaust hose needs to be very flexible for easy installation, but it shouldn't kink even at high temperatures. Now, VETUS exhaust hose is also extremely smooth on the inside to keep the back pressure, the resistance to the engine, as low as possible. And it doesn't get much more flexible than this. I've just tied a knot in it and it still doesn't kink, even if I would raise the temperature. Apart from this, we have a range of elbows at 60 degree, 90 degree angles. We have extension tubes, for instance, where you have to go through a bulkhead. And we also supply heavy duty hose clamps in order to keep the system as safe as possible. The waterlock is the heart of the installation. When the engine is running, it collects the raw water, the seawater from the engine, and pumps it overboard with the help of the exhaust gases. When you stop the engine, the waterlock will collect all of the water that's in the system, so it doesn't damage your engine. At VETUS, we've designed a huge range of waterlocks, and in the next couple of steps we will show you how to select the waterlock that fits your boat, your project. These 3 steps will guide you towards the correct waterlock for your application. Step 1, check the exhaust diameter of the mixing elbow, which is written in the engine manual or in the VETUS catalog. The second step is the physical location. How much room do you have available? How do you connect the in and out hoses to the waterlock? In the third step, we will calculate how large should the waterlock be so that it can contain all the water that's present in the system at shutdown. Now, as an example to check the exhaust diameter, I've taken a page from the VETUS catalog for the VETUS Deutz 6-cylinder 210 horsepower engine. And in the blue circle it says that the exhaust diameter is 125 mm. The waterlock types that are applicable are either the MF, MGS or the HPW 127. And if you need a gooseneck, it's the LT 127. So this narrows down our choices. The VETUS catalog gave us 3 waterlocks to choose from. And now it depends on our choice which waterlock best suits our boat. For instance, the NLP 3 is often used on sailboats to utilize the room underneath the floorboards. The HPW is for larger engine. It's always made from Naviduren, our heavy duty material. The NLP is also often used because you can rotate the top and the bottom independently, and you can even rotate the in and out hose connections. The LS and waterlock series is available with rotating in and outlets as well, so it's our choice which waterlock will fit our application best. The third step is to decide the waterlock size. The more hose there is in the system, the more water there will be in the system, and the waterlock should be large enough to contain all of that water. For the calculation, only use hose that runs down towards the waterlock, for instance an elevated point running to the exhaust fitting where water runs out of the boat, you don't have to include. So all of the hoses that should be included in the calculation are now marked in blue. This is the hose length to calculate. To estimate the amount of water in the system during shutdown, we take half the volume of the hoses. In this table you can see how much water there will be in the system per meter of hose length. So a hose with a diameter of 305 mm will contain a whopping 37 liters per meter of hose. As an example, if you have 5 meters of hose with a diameter of 76 mm, there will be 5 times 2.3 is 11.5 liters in the system. So any waterlock over 12 liters in volume will be large enough. Before you start installing the system, it's a good idea to make a sketch and check a couple of dimensions. From the mixing elbow, the hose downward should be at least 30 centimeters in length, as straight as possible and as downward as possible. Second, sketch in the waterline level at 15 centimeters, and if that line is over or close to the mixing elbow, you have to put in an air vent. It's always a good idea to put an air vent in the system and make sure that it's a minimum of 40 centimeters above waterline level. The gooseneck protects the system against waves hitting the back of the boat that might force their way into the exhaust system. The minimum height of the highest point is 45 centimeters, and you don't want to go over 150 centimeters, otherwise you create excessive back pressure in the system. A gooseneck creates a high point in the exhaust system so that water cannot enter your exhaust. Think of waves hitting the back of the boat, but also sailboats while they are sailing, they are heeling over, and under no circumstances should water be allowed to enter your exhaust. You can form a gooseneck with our very flexible hose, but in many cases it will be easier to install an NLPG with its rotating top and rotating in and outlets. On larger boats, we supply the LT series of goosenecks that run up to 127 mm diameter. If you prefer an extremely quiet installation, you can use a gas water separator. A normal waterlock will always pump out water, and that can be a little bit noisy. A gas water separator separates the exhaust gases from the water, so water is drained from the bottom and exhaust gases very quietly exit out of the top fitting. On fast boats, you can have the situation where there's not enough room underneath the engine to fit a waterlock. But if you have a continuous downslope from engine towards the transom, you can fit a muffler to dampen the exhaust noise. Keep in mind you might have a situation where you have hot gases on top, cold water on the bottom of the hose, so typically you need an exhaust mixer to make sure that the gases are cooled sufficiently. The final part of the exhaust system is the transom connection. These are typically fitted with a non-retour valve, so any waves is already blocked before it can enter your system. At VETUS we have different kind of systems for different boats, depending on the looks that you want to achieve. Twin exhausts are getting more and more popular, but keep in mind that if your exhaust hose is 90 mm, 2 times 45 mm is a lot less in cross section than 1 time 90 mm. In this video we've looked at the main task of the exhaust system, which is to protect your engine from the ingress of water, the main components, the waterlock, the gooseneck, the hoses, additional components such as the exhaust alarm and the air vent, and also on how to choose the correct water lock for your application. I would like to thank you for your time and attention. If you have additional questions, ask them in the comments below or send us an email through the website vetus.com or contact your local VETUS dealer. Thank you very much, and I wish you a lot of good times out on the water.